Hello, welcome again to allheaddeals.com. I am your host for the day. In the last session, we had a quick look at our company and the general idea of e-commerce and its growth in India. Our sessions from here on will start from the very basics and focus more on practical aspects. The topic of our study in today's session is to develop a good understanding of the Internet. We will familiarize ourselves with aspects like what exactly the Internet is, how it works behind the scenes, and we will see some practical demonstrations to understand these concepts better. We hope you will like today's sessions. So let's get started. We live in a digital age today. All of us know or have heard that the Internet plays a key role in business, communication, and economy today. It would not be unfair to say that the world has actually become highly dependent on this one single factor called the Internet. Wherever you go, whatever you do, most parts of our daily lives today are directly or indirectly influenced by the Internet. Be it ticketing, shopping, banking, communication, or be it entertainment, everything is happening over the Internet today. The big question that arises now is, what exactly is the Internet? How did it become so powerful, and how have our lives become so very dependent upon the Internet? Well, to start understanding what the Internet is, let's start with a small example. Suppose you connect two computers with a cable. What do you expect? Naturally, you expect the two computers to be able to share data and collaborate with each other. Now, if we add another computer to this scenario and connect it to the existing two computers, what do you expect? Again, you now expect all three of these computers to share data with each other. Now think of it on a larger macro level. Try imagining all of the world's computers like this. What you are seeing now is a rough representation of the Internet. It is nothing but just a huge network of a lot of computers of the world connected together, which are all able to share data and collaborate with each other. So simply put, the Internet is a collection of various smaller networks connected together to form a big network for the purpose of intercommunication. Some of the computers in this network are meant for special roles like serving websites, providing email service, etc. These computers are called servers and are meant exclusively for providing these services to other computers connected to the network. As end users, we connect to this network through an ISP or an internet service provider company like Airtel, BSNL, etc. We connect to these companies, which in turn are connected to the global network. So now that you have a clear picture of what exactly the Internet is, we move to the next part. The question now is, how does the Internet work? The whole of the Internet works on a client-server model. What this means is that in the case of most of the transactions on the Internet, there is always a computer which requests for a service and another computer which provides that service. Let's take a simple example of opening a website like yahoo.com. Even in this simple operation, your computer is the client computer and the computer providing the service may be located at another corner of the world. The whole process starts with your computer sending a request to the server. The server at the other end responds with the first page of the website that you wish to see. This whole process takes less than a second. But within this time, your request may have traveled to America and come back. Precisely the same operation happens for any activity over the internet, be it sending an email, chatting to someone over the internet, or making a bank transaction. The concept of a request by a client and a reply by the server remains uniform. So to summarize, the internet is a collection of many smaller networks connected together, and most of its functionality is dependent upon the request and reply mechanism of a client-server model. To better understand this concept, let's perform a small practical exercise. We are going to perform a practical on the ping command. The ping command is a method to test your connectivity to any computer or website in the world. We will try to test our connectivity to yahoo.com web server by pinging it. A ping is like an echo. You send a ping request to the server and it returns your request back with a reply. If the reply is received perfectly, it means your connectivity to that computer or website is working perfectly. To perform this practical, you need a computer connected to the internet. On such a computer, go to the Run prompt or press Windows plus R key combination on your keyboard. On this prompt, write CMD and press Enter. This will open up the command prompt of your computer. Now on this command prompt, write ping, give a space, write yahoo.com and now press Enter. Now wait for a few seconds. Let's analyze the result that you got here. It says pinging yahoo.com with 32 bytes of data, which means that your computer is sending a request to yahoo.com. In response, what you get is this: reply from, IP address. This is the address of the yahoo.com web server. Bytes equal to 32, time equal to x milliseconds, TTL equal to 53. This means that the server at yahoo.com has replied and it took x milliseconds for our computer to receive this reply. Further, there are statistics shown at the bottom. It says ping statistics, for example, 98.139.127.62. Packets sent equal to 4, received equal to 4, lost equal to 0, meaning 0% loss. Approximate round trip times in milliseconds: minimum equal to x milliseconds, maximum equal to y milliseconds, average equal to z milliseconds. Now this means that our computer sent 4 request data packets to yahoo.com. Out of these 4 packets, all 4 were returned and there was a 0% loss ratio. Further, it says that the minimum time it took for a packet to come back was x milliseconds, whereas the maximum was y milliseconds, which puts the average around z milliseconds. With this experiment, you can clearly see how a request and a reply mechanism really works and how it is making the whole of the internet work on this principle. In the next section, we are going to have a look at the various physical components which make up the internet. we will discuss all about the computers, the cables, the routers, and the servers. In this section, let's try and understand the physical infrastructure which is actually running the internet of today. This is a layman representation of the internet in graphical terms. As you can see in this figure, there is a client computer connected to the internet through an internet service provider. The internet is represented as a cloud, and it says routers are behind the cloud. At the other end, there is a server kept to entertain the request from the client. Please note that this is a simplistic representation, and the server may actually be located thousands of miles away in another corner of the world. Now let's try and understand this diagram. The client computer here is your own computer. This is any normal computer being used to access the internet. This client computer is connected to what looks like a cloud through an ISP. The ISP is the company that provides internet services to you, and the cloud here represents the giant network that is the internet. The reason it is represented by a cloud is to mask the complexity of the network behind it and represent it quite simply to you. What lies behind the cloud is usually a collection of many devices that form the internet backbone. One of the most commonly found devices is a router. A router is basically a device which shows your packet the best path to reach the server at the other end. Moving ahead, the server is again a computer, usually a bigger computer built with the purpose of providing a specific or many such services to multiple clients at a time. The service being provided could be a website, it could be the email service, or it could be some other service. To have a detailed understanding of these components, a client looks like a usual computer, normally like this. A router looks like this. And a server may look like this or even this. The cables that connect the whole world are optical fiber cables that look like this. Some of the times they are underground cables. Some of the times these cables even go under the sea to connect two continents. This is a representation of an underground optical fiber cable. And this is a representation of an undersea optical fiber cable. To understand the architecture of the internet better, let's have a look at this picture. This picture represents the map of the whole of the undersea cables which connect us globally. As you can see, there are bunches and bunches of cables connecting Europe with America and similarly other parts of the world. These cables are mostly owned by big ISP companies throughout the world. In the next section, we will perform a small experiment to understand and visualize the global nature of the internet. To understand the global nature of the internet, I have another beautiful visual experiment for you. This practical demonstration is called Visual Trace Route. In this experiment, we will try and trace the actual path that a packet takes to reach any specific destination on the internet, for example, yahoo.com. You will actually get to see to which all places does the packet travel and how does it finally reach the destination. To perform this experiment, you will again need a computer connected to the internet. On your computer, open your web browser. Now go to google.com. At google.com, search for visual trace route. Out of the many results that you see, click on the first result, the one at yougetsignal.com. Clicking on this result takes you to this web page. As you can see, there is a text box to enter the destination, the route to which you wish to trace, and there are two options: host trace and proxy trace. As you can see the description below, host trace is a direct trace from this website to the destination, whereas a proxy trace is a trace from our computer to the destination. Our option of choice here is the proxy trace. To start the trace, please type in yahoo.com in the destination box. And now, click on the proxy trace button. Now wait for about 10 to 15 seconds and let the trace be completed. Now, as you can see, the trace is over. Your request packet has traveled from India to the Middle East, to Europe, and finally to America. Within America also, the packet bounced around quite a few times before hitting the final destination, that is, the yahoo.com server. Clicking on any router's name on the right side shows you more of its details, like its IP address and its location. You can further continue this experiment with other destinations as examples. As is very clearly visible from this experiment, the internet is truly global in nature. There are no boundaries when it comes to an internet data packet, and this is precisely what gives the internet the immense power that it possesses today. With this, we wrap up our session on internet working and architecture. We hope you got some worthy information on how the internet is actually working and realize some of the finer points that work behind the scenes. In the next session, we will focus more on the details of the internet operations and some more facts and figures about it. Thank you so much for your time today. We hope you liked the session. Please stay tuned for more.